Okay. Hello, everyone. Welcome to today's webinar, Meeting Code with GFCI Receptacles with Legrand. I'm your host, Timothy Johnson, Digital Editor for Electrical Contractor Magazine. Before we get started, I want to go over some housekeeping items. The audio for today's presentation should be coming through computer speakers or headphones. If you prefer to call in, there's a toll-free number in the event info panel. If you have other difficulties, please reach out to me using the chat window. Also, please note that today's presentation is being recorded, so if you miss anything or something comes up and you have to leave, you can come back at your convenience. I'll send an email out to everyone who's registered after the events close. Finally, there will be a time for Q&A after the presentation. You can submit questions through the Q&A box or comments in the chat box. If you're having trouble finding those features, hover your mouse at the top of your screen and a control panel will drop down and you should see those options there. Now we're going to get on with the show. Our presenter today is Oleg Dratsch. Oleg is the Senior Product Manager for Legrand. In his role, he manages the Pass Seymour GFCI, AFCI, and lighting control product categories. With a customer-centric approach, Oleg has spent nearly 15 years in the manufacturing industry focused on research and development, strategic marketing, and sales. Thank you, everybody, for attending. Now I'm going to go ahead and hand it over to Oleg Dratsch to get started. Oleg?
Thanks, Tim. Good afternoon, everybody. Thanks for taking the time out of your day to listen to the Meeting Code with GFCI Receptacles presentation. We're going to go over a history of GFCIs and their advancement in the National Electric Code. We'll touch briefly on AFCIs and their evolving National Electric Code requirements. And we'll go over some of the results of some marketing studies we conducted on the best methods of following new code requirements as they relate to GFCIs and AFCIs. And as Tim mentioned, we'll take some questions at the end. So let's get started. The history of GFCIs and the National Electric Code. So a gentleman named Charles Dalziel, who is a professor of electrical engineering and computer sciences at UC Berkeley, invented the concept of ground fault circuit interruption while studying the effects of electricity on humans and animals. So essentially what he did was he discovered the let-go threshold. And so what this is it's the threshold of current through the human body that the human body can let go of. And that number is 10 milliamps. Anything above that, and it begins to be problematic for the human body. So at 15 milliamps, muscles begin to freeze in 50% of the population. At 30 milliamps, people have difficulty breathing and fibrillation occurs in children. And at 50 milliamps and above, heart paralysis and tissue and organ burning can occur. This concept of the ground fault circuit interrupter was very important. As Charles Dalziel was the one to invent it, Pass Seymour was the first one to commercialize it. So essentially a GFCI is a device that everyone is very familiar with, but how it works is there's a differential current transformer within the device. And this differential current transformer monitors the imbalance of current between the hot and neutral conductor of a given circuit. The current returning to the power supply in a typical two-wire circuit will be equal to the current leaving the power supply. If the difference between the current leaving and returning through the transformer exceeds 5 milliamps, then the circuit is de-energized. So that's very important. So this gentleman, Charles Dalziel, figured out that anything above 10 milliamps would be dangerous to the human body. And Pass Seymour commercialized this concept into a device that would trip when it found an imbalance of current greater than 5 milliamps. So in the early 1970s, GFCIs were initially required for underwater light fixtures in swimming pools. As the life-saving benefits of GFCIs became more apparent, the National Electric Code added requirements for these devices in kitchens, bathrooms, garages, marinas and boatyards, spas and hot tubs, on rooftops, and more. You can see at the chart at the bottom of this page how the requirements for GFCIs in the home have proliferated over the years, starting with outdoor receptacles in 1973, moving on to bathrooms in 1975, garages in 78, and then on down the line to where we are today, which is GFCIs are required in bathrooms, garages, all outdoor receptacles, balconies, decks and porches, kitchen countertops, within 6 feet of any household sink, laundry areas, and within 6 feet of any bathtub or shower. So with that, GFCIs have been a big help in consumer safety. According to the Electrical Safety Foundation, GFCIs have saved thousands of lives and have drastically reduced the number of home electrocutions since their introduction in the 1970s. Before the installation of GFCIs, nearly 700 people died annually from household electrocutions. Now that number is less than 100 people annually. So this has been a huge safety device throughout the American households. And some of the statistics on this page back that up even further. Down at the very bottom, you can see that 50% of American homes were built before the introduction of GFCIs, and that there are potentially 43 million American homes without GFCI protection. Now, AFCIs, which stands for Arc Fault Circuit Interrupter, is a different type of device that is used to prevent fires in households due to faulty wiring of appliances, vacuum cleaner cords, or electrical wiring within the walls. It's a relatively newer technology as compared to GFCIs. They were first required in the 2002 National Electric Code for circuits with any outlet in a bedroom. In 2008, AFCI requirements were expanded to circuits with outlets in family rooms, dining rooms, living rooms, bedrooms, closets, and hallways, among other locations. And in 2014 was the first year that AFCI protection overlapped into kitchens and laundry rooms, areas formerly covered by only GFCI requirements. So you see at the right here the chart that shows where AFCI protection is required and where GFCI protection is required, and we've pointed out that kitchens and laundry rooms now require both. So to reiterate, 2014 and 2017 National Electric Code requires both AFCI and GFCI protection in kitchens and laundry rooms. There are two options to meet code. The first is to use a dual function AFCI GFCI circuit breaker. The second option is to use an AFCI circuit breaker paired with the GFCI receptacle. You'll see at the right here the code adoption map throughout America, and basically a lot of states have adopted the 2017 code and a lot have adopted the 2014 code. And you'll see in blue and green there states that are still on older cycles of the code. Now, many states have opted not to adopt the extra AFCI protection required in kitchens and laundry rooms because of nuisance tripping associated with dual function AFCI, GFCI circuit breakers. So particularly North Carolina and Oregon have chosen not to adopt this portion of the code, mainly because of the nuisance tripping associated with these dual function AFCI, GFCI circuit breakers. So what we've done is we've commissioned a study, and this was an anonymous third-party study to take a look at the circuit protection market of AFCIs and GFCIs, as well as circuit breakers and load centers. The objective of this study was to provide information on these markets, including customer preferences, trends, competitors, and purchasing processes as they relate to the code change status. We also wanted to provide our customers with answers as to what devices to use when these new code requirements came into place. So we had many people coming asking us for advice on the best way to meet these requirements. So that was an objective of the study as well. So we talked to manufacturers and electrical contractors and electrical distributors, engineering firms, home builders, inspectors, insurance companies, and personnel from underwriters, laboratories, and the NFPA. And the following slides will go over the results of that study and what we found. So the market feedback from the adoption of the latest code requiring AFCIs and GFCIs in kitchens and laundry rooms goes as follows. And this is a summary of our research. And it says, adoption of the 2014 and 2017 code changes is not universal. And where it is being implemented, the implementation of change is occurring at different paces in different states. The following are some quotes that resonated with us and showed what the market preference is. Contractors are creatures of habit. You do not universally see the GFCI going to the breakers. Dual breakers haven't really taken off in all markets. Next quote, GFCI receptacles are still the primary way to address code in many rooms that have water. Next quote, manufacturers would like to see dual breakers force GFCI out of the receptacle, but electricians control the decision. Dual breakers just have not been the huge hit that was anticipated. And finally, most contractors agree that GFCI receptacles are not going away. So again, this is the culmination of research of electrical contractors and electricians throughout America. So basically, they're still fans of the GFCI receptacle, and that's what we want to talk to you about today. So while sifting through hundreds of pages of research, these two graphs resonated most with me. So on the left, you have specific issues with dual function AFCI, GFCI breakers. So this is the result of talking to electricians and contractors that have used these devices. 60% of them have experienced unwanted nuisance tripping when using dual function AFCI, GFCI circuit breakers. 56% of them had homeowners that had difficulty determining the cause of power loss. 47% received complaints from homeowners not wanting to go to remote service panels to reset power. And finally, 31% had difficulty troubleshooting when making service calls. On the right here, you'll see the thing that stands out the most is contractors using dual function AFCI, GFCI circuit breakers experienced nuisance tripping that resulted in a callback 85% of the time. So these are issues that need to be uncovered and need to be talked about. Now, when we compiled this market feedback, basically what we found was that GFCI receptacles are still the preferred choice amongst electricians and contractors. I'll go over some of the survey results. The number one thing was the accessibility for homeowners. So point of use GFCI receptacles allow homeowners to see and reset trips when they occur. AFCI, GFCI circuit breakers are often hidden in remote service panels, which can be inconvenient and challenging to access. And when I say that, I mean with people with disabilities or the elderly or parents with small children are really against this type of change to the National Electric Code. 86% of electrical contractors surveyed said GFCI receptacles installed in the living space are more accessible than dual function AFCI, GFCI circuit breakers. And 47% said they received complaints from homeowners not wanting to go to a remote service panel to reset power. GFCI receptacles are preferred because they're easier to test and reset, resulting in fewer callbacks for the contractor. GFCI receptacles have a trip indicator light, and they test reset easily with a push of a button. Circuit breakers are very confusing and unfamiliar to many homeowners, making it difficult to determine the reason for the loss of power. 56% of electrical contractors surveyed stated that the homeowner's inability to determine the cause of power loss was an issue with dual function AFCI, GFCI circuit breakers. Another reason why GFCI receptacles were preferred by those in the study is the ability to prevent problems. A ground fault trip can happen, and without a GFCI receptacle that is accessible and easy to see, trips can easily go unnoticed. This can lead to power loss, and this can compromise sump pumps, refrigerators, freezers, air conditioning condensate pumps that can result in flooded basements or even more expensive property damage. And with that, 60% of electrical contractors say that nuisance tripping is an issue with dual function AFCI, GFCI circuit breakers. And also 85% said that nuisance tripping with dual function AFCI, GFCI breakers has resulted in a callback for them. Another reason why GFCI receptacles are preferred, they are easier to troubleshoot. GFCI receptacles only trip for ground faults. AFCI, GFCI circuit breakers trip for many reasons. 88% of electrical contractors surveyed said that it's easier to troubleshoot a ground fault trip when using an AFCI breaker and a GFCI receptacle. We've had numerous people tell us that consumers have removed these devices, the AFCI, GFCI circuit breakers, because they're unable to determine the cause of nuisance tripping and are unwilling to pay to have it investigated. So we've had people tell us that they've removed these devices and replaced them with standard circuit breakers, which can potentially leave them in a dangerous situation where liability could be had all the way around. Circuit breaker manufacturers are also producing EMI filters to reduce the nuisance tripping with their dual function devices. These are things that need to be taken into account when deciding how to meet the code for kitchens and laundry rooms. And finally, the fifth most popular reason as to why GFCI receptacles are preferred is the superior protection they offer. GFCI receptacles are proven, they're reliable, they've been around for 50 years. They are required to respond to 7 out of 7 end-of-life events by UL, whereas GFCI breakers are only required to respond to 5 out of 7 end-of-life events. And so as appliances in kitchens and laundry rooms become more and more electrically sophisticated, the nuisance tripping issues associated with dual function AFCI, GFCI circuit breakers are becoming more and more problematic. So we've taken all this research and we've compiled it into some fact sheets, some brochures, a white paper, and even a video that you see the link on the bottom of the page here too. Tim will send this out after the presentation. You'll be able to visit the video, visit the web page, and download these if you want to read through them, if you have questions, if you want to pass them along. All of this information, all these informational tools can be found at our website, www.legrand.us/GFCI. So in summary, some important points to remember. GFCI receptacles offer powerful point-of-use protection. Putting GFCI protection within arm's reach means easier access for homeowners. If they can see the trip, they can reset the trip, and they can prevent larger problems from happening. Dual function AFCI, GFCI circuit breakers are prone to nuisance tripping, often resulting in the unsafe removal of the device that we discussed earlier. GFCI receptacle protection is an owner-friendly, point-of-use, time-tested solution that is familiar to homeowners and has been around for over 50 years. Another important point to remember, a visible indication of the trip will eliminate contractor callbacks since homeowners can usually resolve these themselves. Ultimately, contractors have a choice, but as I've mentioned and as I'll summarize here, our research has shown that AFCI circuit breakers paired with a GFCI receptacle is oftentimes the most cost-effective solution for meeting new code in kitchens and laundry rooms. And with that, I'll turn it back over to Tim.
Thanks, Oleg. That was really interesting. It's kind of funny. I just want to share so quick that you talked about contractor callbacks on visual indication of GFCI outlet trips. We actually have a story. It's in one of our columns. I want to say it's in our February or March issue that isn't out yet, but it's our residential column, and David Shapiro, our residential contractor columnist, actually talks specifically about that and how this one customer of hers, he tried to help her over the phone and he couldn't, so he actually had to go to her home, and sure enough, it was just the GFCI was tripped, and she couldn't push the button in, so he helped her, but it's kind of a funny story. Yeah, we've got some good questions, but if anybody listening has any other questions, please feel free to ask in the Q&A box in the bottom right of your screen. But we're going to go ahead and roll into those now. So first question is there a difference in code requirements for new construction and remodel?
Yes, there is. So for new construction, that's where you would typically use the GFCI receptacle with the AFCI circuit breaker. That's where those two devices would be paired. In a remodel situation, the code allows you to use a dual function AFCI GFCI receptacle, which is a product that Pass Seymour Legrand sells. So that is approved in remodel. That's important to note. As I've met with people across the country, a lot of folks are not aware that that is approved for remodel and that there are devices out there to meet code for those instances.
Okay. Next question. Are you working with any other outside groups to deliver this message?
Yes, we are. In fact, there's been a lot of folks, most notably those folks that are running organizations for people with disabilities or advocating for the elderly or parents with small children. Those types of groups are very, very interested in this message. They do not want to see the GFCI go away. For those types of folks that would have difficulty getting into a basement, that are very unfamiliar with the circuit breaker, this would be life-altering for them. It's very important to these types of folks that we keep the GFCI at the point of use. It's something they're familiar with. It's something they know. A lot of folks it would be very difficult to teach them a new mentality of having to go down to the garage or out to the garage or down to the basement every single time they needed to reset a GFCI device or circuit breaker.
Okay. The next question is, have you found a preference amongst homeowners?
Yes, every homeowner we've talked to, through contractors or through distributors or friends of friends that have heard about this message, they're very adamant that they do not want to see the GFCI receptacles go away from the kitchens and the laundry rooms and anywhere else throughout the house. It's very familiar to them. It's very easy to them. A lot of people, especially homeowners, are not familiar with nuisance tripping, and it's just something that, frankly, I don't think they should have to deal with. They know this technology. They know how it works, and this is something that they should continue to be able to use, and that's been mainly the preference from the groups of homeowners that we've talked to.
Okay. Next question. Are GFCIs still required in crawl spaces?
GFCIs, yes, are still required in crawl spaces, correct.
How often do GFCIs need to be tested?
The latest version of the code, the latest version of UL Standard 943 requires that GFCI devices self-test themselves every 3 hours. The Pass Seymour device actually does it every 3 seconds, which is tops in the industry, but that is something that UL has implemented, that GFCI devices must self-test every 3 hours. Prior to that, prior to this latest version of UL Standard 943, you had to test and reset them monthly yourselves. So this is actually something very good that UL has done to show that these devices are still working properly.
Okay. There was another question that I think would be good to just roll into, and how often do GFCIs need to be replaced?
So today's GFCIs have a, like I touched on in the presentation, an end of life, a series of events that could happen that could determine that it's end of life. And most of them will show either it's a solid red light, other manufacturers may be different, but you'll see a visible indication that GFCI device is no longer protecting the receptacle. And with that, with today's standards, a lot of companies have different ways of attacking this. We call ours our safe lock protection, but power, if any of the critical components in the GFCI device fails, power to the face of the device will be denied, and there will be a visible indication telling you that you need to replace that device.
Okay, and I don't know if there's a standard in the industry or if Legrand has anything, but is there a life expectancy of GFCI receptacles where average time where they might fail or be unable to be reset?
There really isn't. We've had them last for dozens of years, but a lot of variables factor into that. So the location of installation, is it outdoors, is it indoors, is there moisture? So there's really no set standard for that in the industry.
Okay. Next question. Does the use of push-in wire connection versus screw terminal connections on AFCI receptacles decrease the chance of nuisance tripping?
I think in extreme circumstances it would. I mean, if you loop wire a receptacle, a GFCI or AFCI receptacle, you have much less of a chance of arcing occurring. But I think that would be in extreme cases. I don't think we don't see many of those cases that come about. But yes, in general, loop wiring, side wiring is the preferred method and will give you a more solid connection.
Okay. Is the nuisance tripping more associated with the dual function breakers or the AFCI technology?
It's more associated with dual function breakers. I think it's a product of, this is a relatively new technology combining these types of circuitries into one device, and there's a whole host of different of noise on a circuit that could cause these devices to trip. So you have to design around that. You know, a certain appliance may have a specific frequency it operates at that might propagate itself onto the line, and that could cause a nuisance tripping. So there's certain appliances, certain devices that are more prone to causing a nuisance tripping. But yes, to answer your question, it is more associated with the dual function devices.
Okay. Do you know if there have been any changes to the NEC for hotel guest rooms?
That's a good question. They require AFCI protection, and they follow similar requirements as residential construction would for GFCIs.
Okay. Let's see. Has a GFCI receptacle being improved to accommodate today's pitching equipment in residential and commercial? Sometimes there's too much nuisance tripping with the motors and warming elements. So I think, just after reading that, I think clearing it up a little bit, have GFCI receptacles been improved for residential and commercial use? And the comment is sometimes there's too much nuisance tripping, I guess, when there's motors and warming elements on the circuit.
Yep, absolutely. Great question. So typically, yeah, we're always working on the GFCI device. We're always introducing new loads to the circuit to determine if any nuisance tripping would occur. Anytime we hear of something that may be an issue, we purchase that device, we bring it in-house, and we add it to our test plan, and those types of devices are tested on all future GFCIs. So yes, that is something, it's a culture of continuous improvement as far as that goes, and yes, we are continuing to test and add new devices to our testing plan.
Okay. So this next one's kind of a specific, I think, use case. So this person is doing a job in a healthcare facility, and the owner wants him to install a GFCI for the dialysis machine because it uses filtered water for the dialysis, and they want to know if that's a good idea or not.
I'm sorry, can you repeat the last part again?
They want to know if it's a good idea or not to use a GFCI for a dialysis machine.
They're not required in non-critical care areas, so it depends how the hospital defines that, really, is the answer to that.
Yeah. Okay. Let's see. Next question is, what is the best suitable rating for selecting a GFCI?
I'm sorry, what is the best what rating?
Suitability rating? Suitable rating?
Not really familiar with that. We might have to take that one offline.
Okay. Okay, moving on. Do you recommend everything on the circuit, including lighting, be put on a load side or of a GFCI, or just the receptacles?
Yeah, that would be fine. Doing it that way would be fine.
Okay. This one's about older homes. Sometimes they have a smaller metal receptacle and switch boxes that have a maximum number of conductors with very little available space for a GFCI receptacle. Is the combination device larger in size than GFCI?
The combination receptacle device I think you're referring to, there's a slight bump out to it at the back for a toroid housing, and it's a little bit deeper of a device, but they're you know, we design around that. We have those in our office and in our lab, and so we try to fit just about every type of box possible.
Okay. When troubleshooting an AFCI GFCI receptacle, how do you determine what is the cause of a problem, if it's an arc fault problem or a ground fault problem?
Yeah, with the dual function device, there's two separate indicator lights. So for our AFCI GFCI receptacle, you'd have a indicator light for the arc fault side and an indicator light for the ground fault side. So in terms of troubleshooting that, I mean, the ground faults are pretty mainstream, the things that could cause a ground fault. With an AFCI, it's very you know, it's hard to tell. I mean, it requires a lot of kind of trial and error. And with the circuit breakers, it's very difficult to tell because there is no light. So that's kind of what the point I was making earlier was, you know, the device at the circuit breaker could trip. A dual function circuit breaker, you don't know if that's a GFCI problem or if that's an AFCI problem, and there's really no way to tell. And that often results in you know, costly callbacks for the contractor or the homeowner having to pay an electrician.
Okay. Do GFCIs work with motors, such as refrigerators or washers?
Yeah, I think we have up to a 0.5 horsepower rated GFCI that would work with those particular applications.
All right. Do all neutrals have to be segregated on each circuit in an AFCI applications to prevent tripping?
Yeah, with the circuit breakers, yes.
All right. Let's see. Is the code affecting pool installations? Using an AFCI breaker now with the GFCI devices located outside?
Repeat the last part again, Tim.
Sure. I guess the question is whether it's okay to use around pools, whether it's okay to use an AFCI breaker with the GFCI outside. So if you have a GFCI, yeah, go ahead.
Yeah, I think that would be okay. AFCI is not required in outdoor areas or pools. So, but using the GFCI receptacle with the AFCI breaker for outdoor, that would be fine. But you may not need the AFCI breaker.
Okay. Let's see here. I think this is more of a comment, but maybe you can speak to it. The listener said we didn't cover a device with GFCI test reset controls only without a receptacle. They asked because the NEC now requires ready access to these test and reset controls. They wonder if Legrand offers such a product, and they say it would help a lot to have.
Yes, we do have a product. It's called a dead front receptacle, GFCI receptacle. So it offers the protection, but there is no receptacle. It offers GFCI protection, but no receptacle. And those are available in arc fault and GFCI. So yeah, we do have a product for that.
Great. When GFCI self-tests, does the power on that outlet go out?
No, it does not.
Okay. And can you repeat the UL requirement for self-testing?
So UL 943, the latest standard, requires that GFCI devices self-test themselves every 3 hours. So all manufacturers are different. Pass Seymour happens to be the leader in that category. We actually do the self-test every 3 seconds. But really the thought process there was, instead of relying on consumers to test and reset their devices monthly, which a lot of people we found didn't do, UL built this into the standard requiring that the GFCI device itself tests every 3 hours or less.
Okay. So I guess this is another question. I guess the GFCI no longer needs to be tested manually on a monthly basis? Is that right?
that is if you have a newer device. So it's important to know, when your device may be manufactured. If you buy a new device from us today, it's guaranteed to have that technology in it. If you have a house, 20 years back that has GFCIs in it, it will not have that technology.
Yeah, I mean, other than 20 years, do you have a good estimate of time frame in that? Was it a more recent development?
Yes, any device produced by us in the last 3 years will have that self-test functionality in it.
Okay, that's good to know. What is maximum number of receptacles protected by a GFCI?
There's really no limit per the code. So, you could basically, if you have GFCI at the first branch outlet, everything downstream of that is protected. So there's no limit, though, on the amount of receptacles that can be protected.
Okay. This question, I guess they were wondering if we could talk about the difference between indoor and outdoor GFCIs. So
outdoor requires GFCI receptacles. I don't know if you're getting at this, but we do have a weather-resistant GFCI receptacle, and basically that is designed around, it's more robust in the face of that device, in the mounting strap, and then the captive screws. They all have coatings on them to prevent corrosion. So those are, you're starting to see those more and more throughout America, requirements for those going up and up.
Yeah, I guess that makes sense. It's the guts are the same, but it's the exterior that's different. Is that correct?
Correct.
Okay. Let's see. What are the advantages of GFCI over AFCI?
There's really no advantages. It's two different technologies. So GFCI is more of a personal protection device. So, you know, the classic example is you're holding onto a hairdryer, you drop it into a sink of water, well, then you become the path to ground for the electrical current. And that's where the GFCI device will kick in and de-energize the circuit. Whereas the arc fault device is different type of protection. So that protects against actual arcing of the wires, either behind the wall or on the appliances or on your vacuum cleaner cord. So something that may cause a fire. So really two different types of technologies, not really a disadvantage or advantage of one versus the other.
Yeah, we actually got several questions about that. Specifically, I think the overall sentiment is people were wondering, I guess, if you have to go with one or the other, is there one that's better to go with? But I'm gathering that they're sort of complementary. Is that correct?
Yeah, it's all going to be dictated by your local code. So, you know, every state has a different code. Sometimes within the state there's different variations of the code. So it's best to talk with a local electrician or local inspector and to find out what is required. Basically, nationwide, the National Electric Code, those devices overlap, like we mentioned in the presentation, in kitchens and laundry rooms, and that's really it. If you have water, it's typically anywhere. If there's water anywhere nearby, that's where you'll find the GFCI device. And the arc fault devices, the AFCIs, are in other locations throughout the home, like bedrooms and living rooms and dining rooms and those types of locations.
Yeah, we got another question that was wondering if it's necessary for all kitchen receptacles to be GFCI and AFCI protected, but you said water nearby. There's a I think the code determines a distance for that. Is that correct?
Yeah, it's any outlet within 6 feet of a sink. So, you know, there is GFCI required. So you're bound to have at least one of those in pretty much every kitchen.
Okay.
And yeah, exactly. All the outlets require AFCI protection in the kitchen.
Okay. Next question is whether Legrand recommends replacing older GFCIs, the ones that don't self-test. Is there an advantage other than the fact that they self-test?
Yeah, if they don't test and reset, then yes, absolutely we require, or we would definitely recommend you replace them.
Next question. You said at the end of life, power is denied to the face of a GFCI device. Is power also denied to downstream protected outlets?
Yes, it is.
Okay. Let's see. We got a lot of questions in this one. That's great. We already talked about GFCIs outdoors. If a self-testing GFCI fails the self-test, can it be reset or can you manually test it?
No, it cannot be reset.
Is that something where if it fails the self-test, then it's probably failing?
Yeah, in that case, it would have to be replaced.
Okay. This next question, is someone placing themselves in danger by replacing a GFCI for a sump pump with a standard receptacle to avoid basement flooding in a trip during a lightning storm? Would they no longer be in code?
Yeah, potentially that would be a dangerous situation. You would not want to do that.
It sounds pretty unsafe to me. Okay. Do the self-testing devices satisfy OSHA's requirements for testing construction GFCIs?
That's a good question. No, they do not.
Can you speak to what OSHA's requirements are?
Yeah, I'm gonna let our resident GFCI guru, Bill Timmons, answer that question.
I was just going to chime in that
Great.
OSHA has a slightly different requirement. In many cases, they require that the test button still be used. The UL requires the product to have test monthly written on it. So in a lot of cases, OSHA and a safety manager at a big facility will still require that it be tested monthly per the instructions. I mean, they recognize the benefits of self-test, but in a lot of cases, they really go by the book and still require the periodic use of the test button.
All right, Bill Timmons, everyone. Thanks for joining us, Bill. It's great to hear from you.
You're welcome.
I just want to, there's another question, I think, a follow-up to the sump pump one that we talked about. The listener wants to know if there's a workaround. Otherwise, I think the concern is that the basement would flood.
Yeah, I mean, the only workaround I can think of is if you had something upstream of that, another GFCI that you could put in line. But other than that, there's no workaround.
Okay. All right. Are all 120-volt circuits in new construction residential applications? I'm sorry, let me start over. Are all the 120-volt circuits in new residential construction applications, do they require AFCI breakers?
No, not all of them, nope.
Okay. Do you know of any UL-approved electrical corded appliances or equipment that will trip a dual-function GFCI, AFCI receptacle when it's new? In other words, right out of the box.
Any appliances?
Yeah, any appliances or equipment that right out of the box would trip that dual-function receptacle.
I mean, we've heard of devices, but it's not something that we would necessarily be able to verify. But we've heard of that happening.
Yeah, like Oleg said earlier, when there's constantly new appliances and products being introduced, and sometimes they're modified slightly with new electronics, new components, and when we find out about something, you know, we'll check our software and try to find a workaround for it. But everything we sell and manufacture meets all the requirements for UL and our own in-house testing, so that we don't nuisance trip on anything that could be used in-house today.
Yeah, that sounds like a troubleshooting issue to me. Let's see. So here's a pretty good one. It's been the listener's experience that two GFCI receptacles in series with each other don't often fare well. Is that correct?
And there's no reason why they shouldn't.
Okay. Let's see. Looks like we're getting to the end of our questions here. How are you doing on time, Oleg?
I'm fine, Tim.
Okay, I want to be respectful of your time. If anybody else has any other questions, feel free to ask. Okay, here's one. When there are two GFCIs on the same circuit, so it's going back to the last one, similar issue, one of them is failing to reset or the other one trips. Can you think of any reason why?
The one failing to reset, you know, maybe an end of life event. The one tripping, that would be hard to determine. I would try to replace both, and chances are your issue will be solved.
Right. Are your products available through electrical supply houses?
Absolutely.
All right. can you give one circuit to 2 GFCI receptacles in 2 different adjacent rooms?
Got to think about that one for a sec.
No worries.
Yeah, can you repeat it one more time?
Sure. Can you, I guess, so can you have 2 GFCIs in 2 adjacent rooms on the same circuit?
Yeah, in theory, sure.
Okay. All right. I think with that, I'm gonna go ahead and call it a successful event. we answered a lot of questions. So do you have anything else you want to close with, Oleg?
No, that's it. I just want to thank everybody for their time, and if you think of anything in the future, you can email Tim, you can get in touch with me, you can contact Legrand directly, and we'd be happy to help.
Awesome. All right. Well, yeah, I want to thank everybody on behalf of Electrical Contractor Magazine as well, and I want to thank Legrand, and I want to thank you, Oleg, for an awesome presentation, and thanks for sticking around for this extended Q&A. I think it was great. It looked like we got about 78 questions. I don't think we answered all of them, but we got through quite a few. And everyone, just be on the lookout for the recording. We will notify you about that in an email soon. And with that, I'm just going to go ahead and end the event, and we hope to see everybody at a future webinar.